In this video, let us solve this problem. So we have that air at temperature of 5 to 7 degrees Celsius and pressure 30 atmosphere is admitted into the cylinder of an engine. Okay, calculate the pressure of the gas when it has expanded to 5 times its volume and cooled to 127 degrees Celsius as it leaves the engine. Good. Now to solve this, the first thing to do is to write out the parameter given to us. So given that the temperature is 5 to 7 degrees Celsius and this value right here is the initial temperature. So T1 is equal to 5 to 7 degrees Celsius. Now convert this back to Kelvin by adding plus 273. So if you add plus 273 to this, you're going to get 800 Kelvin. Okay, good. And the pressure is 30 atmosphere. So this is the initial pressure. So P1 is equal to 30 atmosphere. Okay, good. So we are then asked to calculate the pressure of the gas. So what will be the pressure of the gas? P2, right, question mark, right, when it has expanded to 5 times its volume. So that means that the final volume, right, V2 is equal to 5 times the initial volume. So the initial volume right here is equal to question mark. We do not have it, right? Good. And cooled to 127 degrees Celsius. So by the time it was expanded and then cooled, this value right here is the final temperature value. So T2 is equal to 127 degrees Celsius. Also convert it back to Kelvin by adding plus 273. So if you add plus 273 to the value in Celsius, you're going to get 400 Kelvin. Okay, good. Now to solve this, we're going to use the formula that says that P1 V1, right, over T1 is equal to P2 V2 over T2. So the value of P1 is 30 atmosphere. So 30 times the value of V1 is unknown. So V1 over the value of T1 is 800 Kelvin over 800 is equal to P2 is the unknown we're looking for. So P2, right, times V2 is 5 times the initial volume. So 5 times the initial volume over T2 is 400 Kelvin. 400. V1 right here cancels V1. You have 30 over 800 is equal to P2 times 5 is 5P2, right, over 400. Okay, good. So 0 cancels 0. 5 here 1. 5 here 80. So what you have left is 3 times 80. Right, 3 times 80 is equal to 80 times P2. 80 times P2. Then solve for P2, right? Divide both sides by 80, right? Over 80, right? 80 cancel 80, 80 divide 80. P2 is equal to 3. So P2 is equal to 3 atmosphere. And this is the final answer.